Hey Bray, so thank you so much for the question. This is a really good one. And I'm not entirely sure what the Year 12 Victoria syllabus looks like because all that I know is that in Queensland, we don't look at combinatorics until Year 11. But I'm going to assume that with this question, it's a part of some kind of combinatorics unit for you guys. And so that's how I'll approach it. What I've done here is just set out, okay, what's the sample size? And started to get an idea of, okay, how many ways can we start arranging this? I think one of the main things here is that anytime you're talking about arrangements, and also you've got the, okay, these books are identical. What you're probably looking at is a permutation of like objects. And that's kind of debatable here, actually. So I'd be really interested to see and hear from you in the comments maybe whether this answer matches what your school has provided or what you found. But yeah, there's a bit of a grey area here, but I'll show you how I'd work it out. To begin, what I've done is I've separated it into, okay, we need a block, so to speak, of 4 Year 10 books. So this is like a block. So we've got our 4 Year 10 books, and what I've done here is just graphically shown that, okay, we can get 6 different options. Got 1, 2, 3, 4, 5, 6. So along this 9 book long bookshelf, there's 6 different ways in which we could have 4 books grouped together. And so that's our first block. We've then got to also consider that there is 5 other positions that need to be filled. And if those can be arranged in different unique ways, which they can, we've got to count them as additional arrangements. I'll just acknowledge it here. So this is where the grey area comes in a little bit. So yes, there are 6 ways in which we can arrange the 10 books. If they weren't identical, right? If we're like, okay, these are Year 10 books, but one's like red, one's green, one's whatever, right? You could also say that, okay, well, there's actually, within that group of 4, there's 4 factorial ways of getting a group of 4 together. Which would give you, okay, well, there's 6 times 4 factorial ways to arrange this block of 4 Year 10 books. Since they're identical, though, I'm not going to be doing that. That may be where the answers differ from my working, and that's okay. I'd love to know that and get some feedback from you there. But I'm going to go with 6 just for now. And so the other thing we can figure out is, okay, if they are like objects, and that's what we're defining them as, we can think about it like, okay, well, if we want to find the total number of arrangements, I'm not sure, again, what kind of formulas you've looked at for combinatorics, but how I look at this is, okay, we have 9 positions we need to fill, and our groups of objects that are alike are 4, 3, and 2. And so our formula for the number of arrangements or the permutations of all of these positions, irrespective of having the books together with absolutely no restrictions, would be this, and I'll put that in my calculator. Okay, and that gives us 1,260, and that's total unique arrangements we can get from all the positions without restrictions. If you're interested, the formula I've used there is this, about the permutation of like objects. If that's not something that you've used in Victoria, apologies for that, but that's what we'd use if this was Queensland Year 11. Alright, so now to finish this off, we've got the total number of arrangements, we've got how many ways you can build a block of 4 Year 10 books. Now we've got to figure out, okay, if we've got our block of Year 10 books, how can we then arrange the other 5 positions, and how many unique ways can we arrange them? And we're going to be using the exact same formula here, based on the assumption that identical books are like objects. What that will look like then is, instead here we've got, we'll label it this time, so permutations of other 5 books is going to equal 5 factorial, because that's the number of positions we're trying to fill, but with the restriction of 3 of these books are the exact same, 2 of these books are the exact same in a different category. And so what that'll give us is 120 divided by 6 times 2. So it's 120 divided by 12 And so that'll give us 10 there. Oops, not 16, 10 ways. And so if there is 6 ways that we can get the block of 10 together, and then 10 different arrangements of the remaining 5 positions, that's then 6 times 10 is 60 total ways, or 60 arrangements, that will result in the year 10 books together. But importantly, we want to find the probability here. So that's not just 60 ways, we got to find 60 divided by the total number of ways, which was 1,260. And we'll go percentage. So we're going to have to times it by 100. And that will give us 4.76%, which feels like a reasonable number here. So that's how I would approach it, using primarily this formula, so the permutation of objects that are alike, and recognizing that, okay, we've kind of got this block here that can appear in 6 different spots. I hope that's helpful. If I've made any mistakes there, or if you use a different approach, please let me know. I'd be really keen to see that, because every chance I'm wrong here, particularly when I don't have the answers. But yeah, I'd love to hear back from you there, Bree. But I really appreciate the question. That's a good one, and thank you.